Hello and welcome to the American Society of Agronomy's webinar. I'd like to now introduce our moderator for today, Dr. Clay Robinson. Dr. Robinson, the floor is all yours.
Thank you, Corey. We're delighted to be able to bring you this webinar today that's sponsored by FarmLink on benchmarking. Our speaker today is Paul Conrad, and Paul is the managing director for FarmLink. He's got 20 years of experience in ag business development and operations. He's also held leadership positions in Weed Control Corporation and AgriLiance, Farmland Industries, and Servitech. He's a certified crop advisor from Kansas and a past board member of the Agricultural Clean Water Alliance. And so, Paul, we appreciate your willingness to participate with us and to share this information on benchmarking. So without further ado, the floor is yours.
Okay, great. Clay, thank you for the introduction. I'd also like to thank the participants today for taking time out of busy schedules to hear about advancements in the hunt for yield. I'd also like to thank the ASA staff for their assistance in facilitating. Today, I'm going to talk about yield benchmarking and its benefits to farmers and agronomists. In the first section of the webinar, my goal is to lay out the process of benchmarking, explain the steps, and expose the challenges that we've been faced with when trying to accurately benchmark yield. The next section will focus on how we can address these challenges in developing yield benchmarking that is both accurate and actionable. Finally, we'll discuss the types of insights we can learn from yield benchmarking, both at the field and farm level, and how these insights can be used to improve yield and revenue. At the end of the webinar, we hope that you have learned a new way to apply technology and data science to more accurately use benchmarking in creating better value to farmers and agronomic advisors. So let's begin by discussing what benchmarking is. Benchmarking is a tool that's commonly used to measure performance. Benchmark provides a reference standard against which other things can be compared. As an example, we can think of the ACTs commonly used in the college admissions process. The ACTs are a benchmark that provide universities a means to compare across applicants and make admissions decisions. In another application, high schools and school districts might use average ACT scores of their student bodies as a means of measuring their relative performance in educating their students. Or principals and school superintendents might use average ACT scores as a way to set goals for future improvement. Benchmarking is not a new process. It's been used for decades across many different industries to facilitate change and improvement. For instance, the automobile industry, J.D. Power, has been benchmarking automaker performance and customer satisfaction since the 1970s. If you consider the agricultural space, for many years we've used benchmarking to measure performance at the industry and farm level. Think about how benchmarking has changed our view of efficiency, for example. We're better able to measure, compare, and improve the performance of our machinery, labor, and input costs, and the time required to complete operations and tasks because of benchmarking. In a prior job, I was responsible for a fleet of 24 row crop sprayers. We were unsure of our efficiency on an acre per machine basis until we benchmarked against a peer set that had similar characteristics. What we found was that when we were performing below, the 50th percentile of others that had like circumstances. So this prompted us to dive into what the others were doing to get better efficiency. That exercise allowed us to implement ideas from others, and we are ultimately able to reduce our fleet size while at the same time improving acres per machine. This helped us tremendously on our balance sheet as well as our income statement. So as I outlined in that example, you can see how benchmarks are used to determine if your performance is above or below others in a group and can inform your decision making to improve or maintain your level of performance. So we have a polling question now that I'm going to send out. And the question is, have you ever used a yield benchmark for your clients? Yes or no? So if you'll take some time and you see that pop up on your screen, go ahead and respond to that. And we will continue the presentation here. So in benchmarking, the accuracy and value created can be impacted by the level of focus. Let's use the example of farm profitability. We all know that total profit per acre is often a key performance indicator for farmers. But comparing a farm's performance to other farms that don't have similar attributes can skew results and will provide a less valuable or less accurate benchmark. If you compare farms of all sizes in all locations to provide a benchmark, the results may be skewed in favor of larger farms due to scale efficiency, in farms in areas of high soil fertility, for example. So your benchmark has some accuracy. Narrowing the focus of your comparisons creates more value because you're comparing to a more relevant peer group. The accuracy of the benchmark increases if we compare total profit per acre of all like-sized farms. The results, however, could still favor farms in areas of high soil fertility, but it is increasing in accuracy. If you narrow the focus even more, it results in greater and greater accuracy. For example, total profit per acre for like-sized farms in like region. This is now a much more accurate benchmark and a much more interesting tool for rating and comparing performance. Think about it this way. Now, would you compare corn and soybean yields on differing soil types, such as a silty loam soil in Iowa, say, versus an alligator clay in Louisiana? Would you measure your own farm's performance by comparing yields from the drought year of 2012 with yields from 2013, when we experienced much more favorable crop conditions? How can you account for the impact of factors like sun, soil, water, and topography in comparing yield? The benchmark gets really interesting and valuable when you compare yields from fields that have similar soil types and other similar characteristics. This is where we can find the real benefit. Yield is a predominant performance indicator for farmers and agronomists. A focused yield benchmark that compares relative relevant performance has tremendous benefit for farmers and agronomists. At the field and zone level, this benchmark can be used to do such things as measure improvement potential within a field, identify key areas within the field to focus efforts, and assist in resource allocation planning. At the farm level, benchmarking supports your efforts for efficiency, sustainability, and conservation of resources. It could also facilitate measuring the success of year-over-year changes in operation and insights on farming practice. And wouldn't it be nice to have results-based knowledge that could inform your land use decisions based on actual performance potential? Done correctly, benchmarking explains how land is truly performing. It exposes where yield opportunity exists and where it might not, and is a tool for measuring the effectiveness of farming practices and input. Okay. To put us on common ground, let's back up and discuss the general steps taken to create a benchmark. There's typically 5 main steps in creating a benchmark. First, you need to define what it is you want to benchmark, right? Second, collect enough data to create a sufficient sample size. You'll also want to review the data for quality. Third, you'll normalize the data. This is a process of eliminating the effects of certain influences in order to allow for more consistent comparisons. Fourth, you analyze the data and develop performance of the data set on a percentile basis. The percentile is the measure indicating what percentage of observations fall below a given value. We'll get into this in a little more detail later in the presentation. The fifth and final step is developing the gap analysis. This means identifying the gaps that exist between your performance, the benchmark performance of others, and your desired performance. It's from this step that you can develop an actionable plan. Again, benchmarking is not a new science, but it's a more complex process than it may seem at first. Let's look at how a farmer and an agronomist might work together to measure yield performance. First, a benchmark's defined. They want to measure yield performance. The metric or measure they would choose is absolute yield in bushels per acre. Next, data is collected. In this case, the agronomist and the farmer compare his yield data against other available data sets, such as test plot results, it might be extension information, or even yields from other farmers who planted the same hybrids. Once collected, the data undergoes some normalization. For instance, the agronomist may split up the data by factors such as soil type or maybe irrigated versus non-irrigated to try and create comparisons that are more apples to apples. A process of ranking and averaging is employed to the data, and a gap is developed between the performance of the farmer and the average results of the other data collected. When looking at the yield map, above average is a good spot. Below average, maybe not so good. This information is used to inform the planning process for future growing seasons. For the most part, this is how yield benchmarking has been happening across agriculture. In some cases it works and performance goes up, and in other cases it doesn't and performance goes down. Now we've all been there, we're rubbing our foreheads, we're trying to figure out why and how to do this so we can attain greater profit and success for our farmer clients. Now it's not you, it's not me, it's your benchmark. So what are the challenges with the scenario we just laid out? What are the challenges that exist in yield benchmarking today? Two general approaches around data collection are collecting precise data on a small scale. Think back to the agronomist and farmer. Or collecting data on a large scale that may have less precision, like some of the major seed, chemical, fertilizer, and even equipment companies do. Specific issues can compromise the quality of the benchmark or limit the feasibility of the exercise. For the local agronomist and farmer, the sample size is too small. Collecting and analyzing data, it can be a slow and manual process. There may be an inability to properly normalize all of the uncontrollable variables. For the major company, controls aren't in place to ensure data quality. Calibration issues can come up. In the end, this means that the benchmark is not comparing like fields with like conditions, and the accuracy and value of the benchmark can decrease. So how can we address the issues and challenges to achieve an accurate yield benchmark that provides value to farmers and agronomists? To provide the focus that will create a result that will be valuable and actionable, the benchmark needs to be defined by potential yield performance on a percentile basis. This represents a change from current practice, which bases the benchmark upon absolute yield. The data collected must be robust. A high-quality database of yields needs to be captured. Data on factors that impact yield, such as sun, soil, water, and topography, should be collected. The old adage of garbage in and garbage out is very relevant when collecting data. The need for good, clean, quality-assured data sets is very important in creating a valuable benchmark. It's a big question. How can you ensure collection of enough quality data? But it's one that could be answered by collecting data over a large geography, say through a managed combine fleet, for example, where you have control over the collection and calibration process. When we get to step 3, you might be asking yourself, how will you manage, normalize, and analyze all this data? It just seems impossible. Well, it's really not. It's now possible using technology and analytics to easily manage this amount of data. Data science and analytics have been transforming how industries gather, review, and use their data to drive profitability. These same processes now revolutionizing agriculture have previously transformed other industries such as the energy industry, the transportation industry, and the telecom industry for years. We can now handle massive amounts of data such as sun, soil, weather, topography, and to normalize for more valuable benchmark results. The ability to normalize the factors that impact yield and the capacity to correlate and analyze data allow the creation of a more accurate and actionable peer-to-peer or like-to-like analysis, resulting in a benchmark farmers or agronomists can use to identify actionable gaps that guide decision-making. And this is where things get really interesting. This is a more visual representation of what I'm talking about. So how can we drill down to compare like acres with like conditions and create a percentile performance curve that identifies that relative performance? Start with the center column of this slide. It represents yield data collected at a very granular level, down to 150 square feet, from tens of thousands of fields, resulting in millions of 150 square foot blocks. Quality assurance processes are developed and employed to solve for those calibration issues, creating a quality database of yield. Data on non-controllable variables of sun, soil, water, and topography that directly impact yield is collected and correlated with the yield field database. This allows for the development of a percentile range of performance for like acres with like conditions. The column to the right shows a sample percentile performance curve. Remember that for accuracy in the benchmark, we want to compare like acres with like conditions. What results is a unique and specific performance curve, connecting the percentile performance to a bushels per acre yield of these thousands of like acres. So in this example, a yield of 94 bushels per acre sits at the 5th performance percentile. 5% of these like acres with like conditions performed less than 94 bushels per acre, and 95% performed at a higher yield level. At the other end of the curve, the 95th percentile, the highest performing of these like acres yielded 192 bushels per acre. Now look at the column on the left, Farmer A's field. For this field, there are thousands of other fields within the database that represent like acres with like conditions. His absolute yield of 153 bushels per acre can be compared on a like-to-like basis to other like acres. This then allows a calculation against the peer set to determine where his yield falls on the distribution curve. Looking back at the performance percentile curve on the right, in this example you can see how Farmer A's field with a yield of 153 puts him at the 55th percentile performance. This means that 55% of like acres with like conditions performed below, and 45% performed at the same or better. The percentile performance can then be used to determine the gap between performance at different levels along the curve. The curve on the left side of the slide shows the current yield of Farmer A's field. His absolute yield is 153, which falls at the 55th percentile. 55% of like acres with like conditions performed below that of Farmer A, and 45% performed the same or above. Farmer A wants to improve the performance of his field so that he's in the top 20% of like acres with like conditions. The curve on the right side of the slide shows where he would fall if he was performing at the 80th percentile. His desired performance compared to like acres with like conditions. To achieve this level, he'd need to harvest 180 bushels per acre for this field. To calculate the yield gap, Farmer A subtracts his existing performance at the 55th percentile, or 153 bushels per acre, from his desired performance at the 80th percentile, which is 180 bushels per acre. So 180 minus 153 equals 27. So 27 bushels per acre is the yield gap to moving from the 55th percentile to the 80th percentile of performance. You'll see another polling question pop up now. Question is, what are the insights yield benchmarking can provide farmers and agronomists? If you'll take some time and respond to that poll. Great. Since yield data in this case is collected at a very granular level, yield gaps can be created at the levels of zones within a field. In this example, the yield for the zone is 167 bushels per acre. If desired performance is to rank at the 75th percentile of like acres with like conditions, the desired performance for this zone is 203. This results in a yield gap of 36 bushels per acre for the zone. This process can be repeated for all zones within a field to generate a gap map. The gap map becomes a powerful tool in determining performance that provides insights that can't be drawn simply from a yield map. So right now, I think it makes sense to pause for just a few minutes, maybe take some questions on what I just went through, and then I'm going to show you what I'm talking about.
All right, Paul, we
Yeah.
have some questions here to start with. So, does the yield benchmark change every year?
Yeah, that's a good question. The range of yields that create the distribution curve will change every year due to the fact that absolute yield, it's a slave to weather events. So one year the range could be 145 to 220, and maybe the next year it's 180 to 240. Now, remember, you're still comparing like to like and normalizing uncontrollable factors such as sun, the soil, the water, and the topography. So even though the yield range changes, your percentile benchmark will still show the performance of acres against like acres. And it's going to show if there was an improvement or not. So yes, it can change.
How about hybrids? You've got so many different kinds of corn hybrids, different lengths, seasons, and stuff. How does it account for those?
Yeah, so if you have the good quality data set and you have the data to be able to create the correlations, you can benchmark performance of hybrids. In the examples I'm using in this presentation, it's not included, but you can benchmark hybrids if you have the data and the other data to correlate.
So I've done some yield benchmarking. How does that affect my prescription when I'm going back to my field to decide what to do?
Yeah, so that's a good question, and it kind of leads into the next part of the presentation here. Benchmarking can help identify gaps for improvement. And so as we talk about on the gap map, these areas can be identified and then dissected in ground truth by farmers and agronomists to determine if a specific prescription is needed to improve the production of that area. And so Clay, we'll go into the next part of the presentation, I think, and that'll become a little bit clearer.
All right, go ahead, and we'll come back with more questions later.
Great. So let's start again. I'll explain more about the gap map and how it can drive those insights. The development of a gap map adds a valuable layer of information for the farmer and agronomist during the planning process. Gap maps developed using an accurate benchmark show where in the field the true opportunity exists and where it might not. So let's consider the examples shown here. As you can see, the blue coloring indicates areas where the yield gap is small, indicating lower improvement potential. And the orange coloring indicate areas where the yield gap is larger, indicating high improvement potential. Again, this map's been developed on a like-to-like basis where those non-controllable variables such as sun, soil, water, and topography are normalized. This information can help you, as an advisor, more quickly focus your discussion with your farmer customers to areas with the greatest opportunities for improvement. Together, using benchmarking with your farmer customer, you can determine where to employ different practices, such as maybe water mitigation, precision planting, it might be split nutrient application, or other best management practices. I recently had a discussion with a farmer. He's looking at his yield map, and he was explaining why a specific area in his field had a lower yield. He told me, he said, the area in that field yields low due to the sandy nature of the soil. And he just kind of blew it off. However, that area compared to other farms with like soil and conditions showed that 40% of other fields were yielding up to 30 bushels per acre more. And it was with the same type of ground and same conditions. So this started a great conversation between the agronomist and the farmer about practices on sandy ground. And after they discussed this for a while, they decided to employ split application of nitrogen instead of applying it all in the fall like the farmer had done historically. They went to more of a liquid with a planter and planned to follow up with side dress application in season. And so the great thing about approaching benchmarking on a percentile basis is that the farmer and the agronomist can look at the benchmark at the harvest following their plan to see if the changes they employed move them up or down the percentile curve. This slide puts the yield map side by side with a gap map, and it's really an interesting and informative comparison. So looking at the yield map on the left, it's clear that the performance of this field was strong. The map shows near uniformity of absolute yield throughout the majority of the field. The yield performance looks really good. However, high yield doesn't necessarily mean high performance. Look at the gap map on the right. It tells us a much different story. You can see that in many parts of the field, there's still significant room for improvement at the 70th percentile. Consider the area circled on the maps. The absolute yield is 203 bushels per acre. That's a good yield. You know, that's one most farmers and agronomists would be happy to have. But it's only performing at the 40th percentile on the performance curve. What that means is that 60% of like fields with like conditions are performing better. By bumping the performance to the 70th percentile, which is a manageable bump, the farmer could realize a yield increase of almost 40 bushels per acre. The farmer in this case might determine a different yield goal for this area. Together with his agronomist, he may employ a prescriptive practice for this area of the field, or therefore, addressing the area of opportunity with a goal to increase his percentile performance. Conversely, in this example, the yield map on the left indicates low performance. Notice the abundance of red and orange indicating low absolute yield. Compare that then to the gap map at the 80th percentile for the same field on the right, and you'll see a different story again. Look again to the circled area. On the left, it is showing 125 bushels per acre, but the performance percentile is actually quite high, the 72nd percentile. If desired performance is at the 80th percentile, the field shows little room for improvement. The opportunity within the circled area is actually less than 5 bushels per acre. Much of the field is performing at the top end of its potential based upon the performance curve compared to like fields with like conditions. If a farmer was trying to push this field to yield like many do by applying inputs in an effort to achieve a higher yield goal, he's most likely not getting the full value of his investment. Armed with this information, a farmer and his agronomist might adjust yield goals and inputs to match its potential, saving or redeploying input and environmental costs. Over time, using the benchmark and gap map, the farmer agronomist might determine whether areas of this farm should be placed in some other use, such as conservation or maybe even hay or pasture. Our third polling question is, does high yield always mean high performance? And I'll give you some time to answer that. And everybody's getting that one right. That's great. Hopefully I'm doing an okay job here. The answer to that is false. Percentile performance benchmarking can also be powerful when analyzing a farm's entire portfolio of fields. Once percentile performance has been calculated for each field, one can quickly identify fields or zones within the portfolio that offer the most opportunity for improvement. Based on that plan, you can budget to ensure that you have enough people, machines, and money when and where you need them. A portfolio view can also be used in year-over-year analysis to measure how implementation of decisions and practices are impacting the portfolio's performance. Ultimately, this kind of knowledge can help farmers and their advisors identify trends and inform intelligent decision-making on land use, improving overall farming outcomes. Let's walk through an analysis on a portfolio of fields. In the scattergram we show here, each blue dot represents a single field within that farmer's portfolio. The x-axis shows the percentile performance rating compared to like fields with like conditions. Remember, this is calculated for each field separately. The y-axis shows the absolute bushels per acre yield. The fields, or the blue dots, are placed on the graph based on their individual performance and benchmark. Then we calculate the averages across a portfolio of fields. The red lines are placed to represent these averages. For this example, the overall portfolio average percentile for the farmer is the 52nd percentile. This is represented by the vertical red line. The horizontal red line represents the average bushels per acre performance for the portfolio, which in this case is 188 bushels per acre. First, let's focus on the fields that fall to the left of the red vertical line. These are fields that perform below the portfolio average percentile performance, which in this case is the 52nd percentile. The fields on the left side of the scattergram are fields that offer high improvement potential. In the upper left-hand quadrant, we see two fields with high absolute yield. They're performing below the portfolio average percentile performance. Now, dissecting these fields would be a good idea. They may have been considered as performing at a top level based on their absolute yield, but the percentile performance indicates there's still plenty of opportunity to improve performance. Again, back to high yield does not always mean high performance and no opportunity. In the lower left-hand quadrant, we see multiple fields that were low yielding and low performing. In some cases, a farmer agronomist might identify a disease issue such as Goss's wilt of corn, maybe sudden death in soybeans, a micronutrient issue, drainage issue, or possibly a very localized severe weather event such as flooding or hail that resulted in the low performance. This helps farmers and agronomists in identifying fields to ground truth for these issues. It could also be something that points out areas in fields that should be tiled to remove excess water. In any case, this representation allows for a quick analysis of fields to be ground truth within a portfolio and to begin asking questions to determine if fields would benefit from changing prescriptions, practices, or possibly even land use. Now let's look at the right side of the scattergram. Here we're considering fields that are performing above the 52nd percentile. Fields in the upper right quartile are both high yielding and high performing. Fields in the lower right quartile are fields that are low yielding, however performing towards the top end of the percentile distribution. This is when an agronomist can really help his farmers do the diligence to determine the best course of action for each field and the overall portfolio. So you might ask yourself, what is it about these fields? What are the practices we're employing that could be replicable when we consider other lower performing fields? Should resources being used here be redeployed elsewhere? If we see fields performing, say, above the 95th percentile with high yield, should you look into the economic sustainability of that field? And would it make sense for a farmer to set an upper limit, such as the 85th percentile, based upon economic and environmental sustainability? Knowing where to start to ask these questions is an important first step in determining best practices. So I was talking to an agronomist the other day about one of his customers' higher performing fields. The yield was good across the field, and the gap for improvement was very low in these areas. The agronomist been determining best practices being applied on the high-performing field that could be replicated by this farmer client on other fields. So during the review, we called the farmer, and it became clear after that conversation that part of that field was being double irrigated. The discussion changed, and it focused around the cost of over irrigating, and whether or not we should redeploy resources to areas in that field that still showed opportunity. So what they decided to do is implement some precision irrigation techniques to redeploy the water to areas that had improvement potential. They'll be able to review the benchmark next year to see if whether or not those practices affected overall yield and performance. In this chart, we're going to take a deeper look at how we can identify the fields with the largest improvement potential. We'll measure the yield gap by setting desired performance at the 52nd percentile. Our farmer wants every field to at least match the average portfolio performance. The blue dots again represent individual fields. The y-axis in this case is the yield gap of the field to reach the 52nd percentile. Remember, the yield gap is measured in bushels per acre. The x-axis is field size in acres. The red lines show the averages again. this time for the average field size and the average portfolio yield gap to reach the 52nd percentile. By representing the portfolio fields this way, we can quickly see where the largest opportunity exists. As you can see, when you look at the portfolio this way, there's two fields that appear in the upper right-hand quadrant. This means those fields are above average in size, and they have above average yield gaps to reach the 52nd percentile in performance. These two fields offer the most opportunity in the hunt for yield. Even with $4 a bushel corn, the revenue improvement opportunity is significant. The two fields together represent 320 acres of the entire portfolio and offer more opportunity together, as much as up to $93,000 of additional revenue. By benchmarking fields and portfolios, you and your farmer customers can work together to maximize opportunity within the confines of a budget. We all know there's less room for error at corn under $4 and beans under $9. And that's why I'm excited that agronomists and farmers can now utilize technology and the advancements of data science and analytics to focus action plans and measure results. In talking with farmers and agronomists today, there's a lot of pressure to increase yields while managing cost. It's going to take new technology, better tools, and independent decision-making based on performance to improve farming. Benchmarking is a valuable and time-saving way for agronomists to identify areas of opportunity for their farmer clients in the hunt for yield. This brings me to the end of the presentation today on benchmarking and the hunt for yield. We covered a lot today, the benchmarking process, and how applying technology and data science can provide a high-value benchmark for farmers and agronomists to use in their planning. I hope that you've learned a new way to more accurately apply benchmarking to create better value to farmers and agronomic advisors. We've also provided a few glossary slides at the end of the presentation that define some of the terms used throughout and provide the principles of benchmarking. I'd like to thank everyone for their participation today. I'd also like to thank the ASA for giving me the opportunity to share this knowledge with you. I hope you'll take a moment to learn more about FarmLink's yield benchmarking tool, True Harvest. It's a powerful tool that successfully addresses many of the challenges we've reviewed today. Please visit the links provided at the end of the presentation to learn more about True Harvest and watch a demo video showing how the tool is used. So now, I'll turn this over to the facilitator for questions. Clay?
All right. Thank you again, Paul. Very informative presentation. We've got a good amount of time here to pursue questions, and there have been several come in. So we'll just start out. How do you choose which fields to review in your benchmarking process?
Well, you can look at it several ways as we discussed. You can look for fields that have high areas of improvement on a percentile basis, or take the portfolio approach and look at fields that will give you the most opportunity for improvement. All fields really should be reviewed, as you can learn things from even the top performing fields and acres. But using the gap maps, you can really dial in and identify, create zones within fields to find out where there is improvement opportunity, and that's really where you should focus.
And so what you're telling us is that you can use that benchmark to identify, and the gap maps to figure out if your inputs, your resources are being used well, or if maybe you've got over-application or something in one area that you could redistribute it to an area that's got a greater potential for increase.
Yeah, absolutely.
All right. So can you compare like-to-like zones across all fields first instead of comparing like-to-like fields first? So pick zones rather than fields.
Yeah. So the more granular you get, the better your comparison. You can compare like 150 square foot blocks to other like 150 square foot blocks. You can roll that up into zones, and you can roll that up into fields. So you can create comparisons. When you get more granular, what we've found is most farmers farm by zones, and so as you're looking at a gap map, you can create zones around the gaps that offer improvement opportunity, and compare the benchmark for that zone against other like zones with like conditions.
This next question, I'm going to rephrase it a little bit to see if I've got the context right. But when you're doing your benchmarking, it's looking at like conditions. So maybe that's like soils, particularly the starting point, maybe like climates. It doesn't address management per se, but is the difference that you see in terms of potential for yield increases, is that how management is considered or brought into play?
Right. So when you create the comparisons, you're looking at factors of yield, and then you're looking at factors of sun, soil, water, and topography. And there's trillions of data elements that could factor into that. The management practices are the things that the farmer and the agronomist working together can determine and employ, and then they can use the benchmark the following year to measure the effectiveness of the management technique. So really what you're doing is you're creating a baseline for that farmer's field zones and 150 square foot sections within a field.
All right, so again, just kind of as a follow-up on that one, you don't know what's going on in the management on those other farms, but you know is there's a potential for improving management or in some fashion in those places where there's a gap, and that's what the farmer and the consultant do together, is to determine how to adjust that management. Okay.
Great.
What if you've got a CCA, you've got a single farm? Is there some way to get the data for that regional data to figure out how these things come together? Or is that data only available through services like the one at FarmLink or other companies offer?
Well, yield. So, are you talking about yield data, Clay?
Well, that's. I'm reading you the question as it came in, so I'm not really sure whether they were talking about yield potentially, but they just said, how do I get data from my region to determine where my farm stands? So that probably does start as yield data and then considers those like versus like comparisons. Right.
So farmers can collect yield data through their combines today. We have at FarmLink we've developed technology that has allowed us to collect data, and we do have an owned combine fleet. And so in our benchmarks, we use the data that we collect through our machines, and we have calibration process and some technology that solves for calibration issues. But farmers can also, they have their yield data. The other factors of sun, soil, water, and topography, soil maps from USDA. There's a lot of different weather sources out there for collecting weather data for specific areas, topography, moisture holding capacities of soil, so on and so forth. So there's a lot of public available data that exists that can be pulled in to create correlations.
So then it would be for a specific farm and farmer or CCA working with a specific farm. The challenge then is finding like fields or like conditions on that broader, off their farm. So finding out which neighbors have similar things and yields. So that would be the limitation of the challenge in them finding opportunities for that data to be available.
Yeah. So if you're thinking about the practices too of other, what other farmers are employing that have those like-to-like situations, that's a lot of the ground truthing that an agronomist really brings value to that farmer of knowing, that another farmer they benchmarked that has similar soil characteristics is performing higher up the curve. So what are some of the practices they're employing on those acres that could be deployed for that farmer on his acres?
All right. Then there's a question on how big can the data set be, but the focus that they have on the size of that data set is really regional. How big can the area be when you're trying to consider like soils, climate, and like soils and climate features? How big of a radius can you work within?
Yeah, so when you're comparing like soils, it's going to pull comparisons from it could be the field right next to it. It could be an acre within the ag district. It's comparing the like soil type to like soil type. So it's going to stay in areas that are relevant. Just like in my example, you're not going to compare glacial soils in northern Iowa to alligator clays down in Louisiana. It's going to pull benchmarks from like to like comparisons, and so it can be a significant area in the state of Iowa. It might pull benchmarks from or comparisons from southern Minnesota and Illinois. South Dakota may pull benchmark results from northern Nebraska. So it can spread out on a geography basis, but it's still selecting like to like comparison.
So if they wanted to, and this is my input for you. If you wanted to get a feel for how large that can be, you could go into the USDA Web Soil Survey, and they've got a tool that if you know your soil series, you could put it in, and it'll show you the extent of that soil series where it's been mapped. So that would give you, from your soils perspective, that how large that radius could be. All right, we've got another question. Has anybody ever tried to use this with orchards?
Currently, we have not used this with orchards. We do see the crops expanding. We've been focused at our company on corn, soybeans, and wheat, and we do plan on expanding because we do believe that this can be deployed on many different crops. It could be deployed on canola, orchards. It might be we're doing some work looking at grapes, and so. The challenge is collecting the good quality yield data set that it requires to create those comparisons. And in the case of corn, soybeans, and wheat, we have combines that we can stream data from and create good quality database.
All right, we've got a couple of questions here that are talking about across seasons. So you've talked about doing a benchmarking this year and then making some changes or looking at last year's benchmarking data, making some management decisions and applying those this year. But is it possible to, let's say, take 4, 5, 6 years of performance data, and then maybe you get to more of what a consideration of maybe what would be a true benchmark? Or does that then detract from some of your opportunities? Let's say as you work through that, you are improving one section of the field over another. How does that show up? Can you use those multiple years to get a truer number?
Yeah, that's an excellent question. The value of benchmarking really, really increases when you have multiple years of information to develop trends. So you can employ certain practices this year and look at your benchmark following the harvest. And since you're normalizing the uncontrollable variables, you're still comparing on a percentile to percentile basis. So you can tell whether or not you're moving up or down that distribution curve. And so when you do that, you can take the portfolio approach and you can track fields to find out whether they're moving up or down, and then you can ground truth the reasons why. And so it presents a lot of insight that you don't get when you're not employing benchmarking this way by doing a year-over-year analysis, and the more years you put in that, the more valuable it gets.
I'm going to break this question into two pieces. What's the source of the climate data that you use? You know, you're talking about sun, rain, that kind of stuff. What's the source of the climate data that you tap into?
So we use several different sources for weather data. We use USDA data. We also have a partnership with DTN. And there's a couple others. There's two main ones, and then there's a few others that we use to pull data from to correlate.
Okay, so you've got then in the field, you can go to this really fine 150 by 150 foot square, so a little bitty component of a grid, but
right.
The rainfall precipitation data typically is on a much broader scale. So, and I've known, this one says that you can have abrupt changes in precipitation. Where I used to be in the Texas Panhandle and now in New Mexico, you can find a spot on the road where the rain stops and starts. So that variability can be extremely distinct. How is that accounted for when you've got these little bitty areas of yield on a soil, but you've got broad climate stuff?
Yeah. So, the weather data that's available out there today is pretty advanced. The benchmark won't pick up those extreme weather events like we're talking about. Say, I was looking at benchmarks for a farmer up in South Dakota, and part of the field was very low performing, and the other part was very high performing. Well, he had a hailstorm come through. And you're not going to pick that up in USDA or DTN data. So it's a lot more advanced today than it has been in the past, the kind of geographical weather information that you can get. But it's not precise down to that 150 square feet. So really that's where, input back from a farmer or an agronomist can say, well, down on the southern end of this township, we had one extreme weather event where we received 14 inches of rain, and it drowned everything out. Those are the things you learn. There's things like that come into play. So until we have weather stations on every farm out there, it's going to be very difficult to identify and normalize for extreme weather events like that. But it's much more valuable today than it has been.
Let me follow up with that and just suggest that for those of you who are interested in that idea of getting weather data on a much smaller area, you might go back and look at our erosion segment that aired a few weeks ago on water erosion models. There was one on Russell II and WEP, or Water Erosion Prediction Project. And in that water erosion prediction project, they're using real-time data using radar information. So you might go back and look at that one, see where they're getting that data, and then how they're using it, because it's certainly something that could be brought in this context as the data becomes more readily available. How about percent return on investment? Is that different than looking at the yield gaps?
Well, I think this can help farmers identify return on investment. So it provides a measurement tool, right? So you can measure whether or not practices you're employing are actually moving you up or down the percentile performance curve. And so if you think about whether or not a fungicide application on corn is really paying for itself, if you try and determine that based on absolute bushels, it can be very difficult. But if you're benchmarking, you can do it on a percentile basis and tell whether or not you're actually getting a return. So it provides farmers and agronomists a way to measure ROI on practices and inputs. That's how I would think about it.
All right. There's one on algorithms. I think that would probably be more than time, require more time than you've got. So I'm going to let that one hang out there, and maybe they could look at some of the reference information you provided to get a better perspective on that.
So
somebody was asking.
I pulled up.
Somebody else was also asking for literature references, and I think those are probably things that you've got in those definitions and slides at the end, or at least I suspect.
Yes, and we've provided a slide with a couple links, as well as some contact information. If anyone's interested in learning more or connecting with someone in our data analytics team to talk about algorithms and things like that, we're more than willing to have those discussions.
So what does the highest performing farmer learn year after year? So let's say they come in, most of their fields are coming in at that 85% level. What do they have to learn from this?
Well, they know that what they're doing is keeping them at the top end of the percentile curve. But I think for those types of farmers, it could allow them to really look at it from an economics perspective. And it might not be the 85th percentile, Clay. If you had somebody that was over the 85th percentile on all fields, might really kind of look into both the economic sustainability of that as well as the environmental sustainability of what they're doing.
Yes, there's a law of diminishing returns that tells us that there's a point where your increase in yield from each input starts to decrease, and maybe that's the point where the economic evaluation comes in to be more important. How about you've got slides of within field as well as graphs of whole field. Are those complementary when you're trying to work through this? Or
I'm sorry, ask that again.
Well, okay, that says you've got within field yield, and then you've got graphs of whole field summaries. How do those work together? Do you take an average of all points within a field to get an idea of the percentile performance, or are those separate evaluations?
They're separate evaluations.
All right. Now we've got several other questions that are coming in. One of them said, great presentation, will there be a recording available? And the answer is yes. You've registered for this webinar. If you've registered for this webinar, you will get a link to that recording that will be available for you. If you're, the same thing is true for all those who are listening or plan to listen later. You registered, weren't able to attend the live session. Also, if you've got friends who say, man, you really need to hear this, they can come in later and pay the fee, and they'll be able to access this because it will be in our catalog of self-study materials that are available. And we've had several other questions. We're not going to have time to address all those. You did put your contact information up, so I suspect there will be some people may contact you on these. And at this point, you've been answering questions for 20 minutes. Again, I appreciate your help that you've given, your information. Obviously, this is a very interesting topic to people. So at this point, again, well, thank you, Paul, for your help. We do have one more scheduled online webinar that's coming up next week on Wednesday. It'll be about the UAVs. So what are they being used for? How do they fit? Are they ready? Those kinds of things will be addressed. So what are their uses and what are their limitations at this point? And then for those of you who are already CCAs, we do have some specializations that are on in the pipelines. One of those we hope to launch this fall. These are things that there will be an additional test involved, and maybe some change in the way that you accumulate or apportion your continuing education units. So watch for those on sustainability, on nutrient management, and on IPM, particularly as it relates to resistance management. With that, again, thank you all for your time, and Corey's going to return, and he has a quick survey for you to do.
All right, thanks a lot, Clay. I'd like to now pull up the survey that we were talking about. It should be now on your screen. If you could just take a minute and fill us out, this would definitely help us improve future webinars, and we appreciate all of your feedback. I would like to thank all of you for joining us today and for your participation, and would also like to thank Paul for his excellent presentation today as well. Again, thank you very much for joining us today. We hope you all have a great rest of your afternoon, and you may now disconnect.